Okay, product rule derivative, for derivative. So if we have two functions, f of x and g of x, and both functions are differentiable functions, so then we can say that derivative, the derivative by x for f of x multiplied by g of x will be equal first function multiplied by derivative of second function plus second function multiplied by derivative of first function. Okay, so let's see on example. So we have h of x first one. H of x is equal 3x minus 2x squared multiplied by 5 plus 4x. Okay, based on a product rule, what we're gonna do, derivative h prime of x is equal 3x minus 2x squared multiplied by 5 plus 4x prime, and then plus 5 plus 4x prime multiplied by 3x minus 2x squared. Let me explain. So this is first term, this is second term, yes? So when we multiply first one, multiply by derivative of second prime, and then plus second multiplying by derivative of first one. Okay? So, what we are going to get, h prime of x is equal 3x minus 2x squared, 3x minus 2x squared, because we don't do anything with the first one, but second one we are taking derivative. Derivative of 5, it's going to be constant, right? It's constant, so it's going to be 0. And derivative of 4x, it's going to be 4. Remember, let me remind you, 4x, this is 1, right? So derivative will be 4 times. This 1 will come in front, and here will be left 0 because we do minus 1, right? So what do we get? We are getting 4 times 1, because x to power 0 is 1, which is equal 4, right? Okay, let me clean. And then plus 5 plus 4x multiplied by derivative. So derivative of 3x, it's going to be equal 3, right? Same way like as of 4x, it's going to be equal 3. And derivative of 2x squared, it's going to be equal to, these 2 will come in front, right? 2, and x, 2 minus 1 will be 1. So it's going to be 4x minus 4x in parentheses. Yes, this is a rule from the previous video that x to power n prime is equal n times x to power n minus 1. Okay? All right, so now we need to simplify. H prime of x is equal. We distribute this 4 by this and this. We get 12x minus 8x squared plus, now we need to distribute this one. 5 times 3x, 15. 5 times negative 4x, negative 20x. And then 4x times 3, it's going to be plus 12x. 4x times negative 4x, it's going to be minus 16x squared. Okay, let's then simplify. Combine like terms, rather saying. So what do we get? Negative 20x plus 12x plus 12x, and that's it. So, and negative 8x squared, negative 16x squared. It's going to be negative 24x squared. Now let's combine x's. 12x minus 20x, it's going to be negative 8x. Negative 8x plus 12x is going to be 4, right? Positive 4. And plus 15. Okay, and that is the derivative based on product rule. Let's use another one. Problem number 2. Let's use this time trigonometric function, trig function. Y is equal 3x squared times sine x. Okay, derivative by x for 3x squared times sine x is equal. So first function, which is going to be 3x squared, let me mark down, this is first one. This is second one. Okay, so 3x squared times derivative of sine x all right, plus sine x times derivative by x for 3x squared. Okay, so what do we get? It's going to be equal 3x squared. Derivative of sine x, it's going to be cosine x, right? Because we know that from the previous video, derivative of sine x is cosine x, and derivative of cosine x is negative sine x. Okay, so 3x squared cosine x plus we have sine x, right? Right here, sine x times derivative of 3x squared, so it's going to be 3 times, 2 will come in front, x to power 1, so 6x. Okay, and we will have three x squared cosine x plus 6x sine x. Yes, 3x we can take out this 3x from here and 3x from here, right? And it's going to be x cosine x plus 2 sine x. Okay? All right. One more. I'll solve one more and we move to quotient rule. So what do we have? Y is equal 2x cosine x minus 2 sine x. All right. So what do? We gonna take derivative of y by x. That is equal. See, we have here product, right? 2x times cosine x, which is gonna be equal 2x multiplied by d by dx for cosine x, okay, plus cosine x multiplied by d by dx for 2x and minus 2 sine, okay, let me rewrite because it's a subtraction, so sum and difference, we already learned it, so just take d by dx for 2 sine x, okay? All right. So that's going to be equal 2x multiplied by derivative of cosine x, we mentioned here, is negative sine x, right? Plus cosine x. Derivative of 2x, it's going to be 2, right? Okay, minus. Now, here we are going to, let me see. Here we used product rule. And here we are going to use constant multiple rule. Okay. So, okay, minus derivative of 2 sine x, it's going to be 2 cosine x, right? Because derivative of sine is going to be cosine. And from here, what do we have? It's equal negative 2x sine x plus 2 cosine x and minus 2 cosine x. So this and this is gone, and the answer is negative 2x sine x. Okay, moving to quotient rule. Quotient rule says that if we have two functions, f of x and g of x, and both functions are differentiable, then derivative of a quotient, f of x divided by g of x, is going to be equal derivative of first function multiplied by second function minus derivative of second function multiplied by first function And all that divided by square of the second function, which is denominator. Okay? Let me put square bracket, it will look better. Once you already use parentheses, second one you don't want to use parentheses, but the square brackets for readability. And obviously we have to mark down, since we have division, we have to protect the domain, and which means g of x cannot be equal 0. Okay, so let's do some practicing problems. That was number 3. Let's continue with number 4. Or okay, I can start from 1 again because it's a different rule, quotient rule. And we have y is equal 5x minus 2 over x squared plus 1. So 5x minus 2, it's going to be f of x. X squared plus 1, it's going to be g of x. Okay. So we have f of x prime of f of x, which is going to be prime of 5x minus 2, multiplied by x squared plus 1 minus prime of g of x, which is going to be x squared plus 1 prime, multiplied by f of x, and I'll literally typing f of x instead of writing down the function itself, 5x minus 2, and divided by g of x squared, which is x squared plus 1 squared. Okay? All right. So this is equal, g prime. Well, let me write down one second. Let me fix here. I started taking derivative, and I didn't put down dy by dx. Otherwise, it looks like y is equal. No, it's derivative. Okay, so dy by dx. Okay, and this is equal. Let's see. Derivative of 5x is 5. Derivative of negative 2 is gone, right? It's 0. Multiplied by x squared plus 1. Minus derivative of x squared plus 1. Derivative of x squared is 2x. And derivative of 1 is gone, it's 0. Times 5x minus 2. And divided by x squared plus 1 squared. Okay. Well, let's see. We are getting 5x squared plus 5 minus 10x squared plus 4x, right? Here it is. 10x squared and then plus 4x. And divided by x squared plus 1 to power 2. Okay, that is equal 5x squared minus 10x squared, it is equal negative 5x squared, and plus 4x and plus 5, and divided by x squared plus 1 to power 2. Okay, next one. Second problem for quotient rule. F of x is equal three minus 1 over x over x plus 5. At the point, so we're going to differentiate at the point -1 and 1. Okay. So before we start taking derivative, I'm going to rewrite the original function. To get rid of this fraction 1 over x, to make it easier for me, and that is going to be 3 minus 1 over x, common denominator is what? X, right? And I will get here 3x minus 3, correct? Let me show you here. 3 minus 1 over x. Because common denominator is x, divide by 3, multiply by 3, yes? And we are getting x, 3x minus, 1. Okay, 3x minus 1. Now in denominator, so x plus 5. And once I divide, what am I getting? 3x minus 1 divided by x divided by x plus 5. That is equal 3x minus 1 over x multiplied by 1 over x plus 5. Remember, we have to flip the second fraction and do multiplication. So which means it's going to be 3x minus 1, and at the bottom in denominator we will have x times x plus 5, right? Which will be equal 3x minus 1 and x squared plus 5x. X squared plus 5x. Okay, now let's take apply quotient rule. Okay, take derivative. So f of x, which is derivative, I'm going to write down as f prime of x. And it's going to be equal at the prime of first function, which is 3x minus 1 prime, multiplied by second one, x squared plus 5x, and then minus prime of second one, x squared plus 5x prime, multiplied by first one, 3x minus 1. To make it clear, this is first one, and this is second one. Okay? All right. 3x minus 1 and x squared plus 5x prime. And we divide by second function squared, which is x squared plus 5x to power 2. Let me see if I can bring it down a little bit, leave space. Okay. This prime I can put here. All right. So this is equal f prime of x is equal derivative of 3x, it's going to be free. Derivative of 1, it's going to be gone. So we multiply x squared plus 5x minus derivative of x squared, it's going to be 2x. Derivative of 5x is going to be 5. Multiplied by 3x minus 1. And we're dividing by x squared plus 5x squared. Okay. What we are going to get from here, let's simplify. So 3x squared plus 15x minus 12x times 3x, it's going to be 6x squared. 2x times negative 1 is going to be negative 2x. And then 5 times 3x, it's going to be 15x. And 5 times negative 5, it's going to be negative 5. Divided by x squared plus 5x to power 2. All right? Let's simplify further. 3x squared plus 15x minus, so I'm going to flip every single sign within parentheses. It's going to be minus 6x squared plus 2x plus minus 15x. Not attentive at all today. Minus 15x and plus 5. Let's double check. Negative 6x squared plus 2x minus 15x and plus 5. All is good. X squared plus 5x to power 2. All right. So lastly, if we combine like terms and cancel 15x and negative 15x, we are getting the answer is equal. So it's going to be negative 3x squared, right? Like terms. This like term and this like term, negative 3x squared plus 2x plus 5 over plus 5x squared. Okay, now I would like to show you how sometimes we can avoid using a quotient rule and turn into multiplication rule. So I'm going to show you not tricks but effective way of writing the function. So let's assume we have y is equal x squared plus 3x divided by 6. So once, if you look at glance, it looks like we are going to apply quotient rule because we have fraction. But instead, I'm going to do the following. Take 1 over 6 out and leave here x squared plus 3x. And apply quotient rule to remind, not quotient rule, I'm sorry, constant multiple rule. To remind you, constant multiple rule says derivative by x for c f of x, where c is a constant, yeah, is f of x, yes, it's equal c, constant stays out, and we take derivative only f of x. So as you can see, I could take constant out of derivative. This is a constant multiple rule. The same thing I'm going to apply here. So 1 over 6 will stay out, so y prime will be equal. 1 over 6 will come out, and we will need to take derivative of x squared plus 3x only, right? And that will be equal 1 over 6. Derivative of x squared will be 2x, right? And plus 3. So as a result, it's going to be 2x plus 3 over 6. See, nicely we avoided a quotient rule, and it's much easier to take derivative this way. Another one. Okay, next one. Y is equal 5x to 4 over 8. Okay, again, I'm taking out 5 over 8 and taking x to 4. So from here, derivative will be 5 over 8. So instead of x to 4 will be 4x to 3, right? Okay, and that will be equal at the 5 over 2, because 4 and 8, this will be 1, this will be 2, right? 5 over 2x cubed. Let me try two more tricks to show. Y is equal negative 3 times 3x minus 2x squared over 7x this time. I'm going to represent negative 3 over 7 and divide every single term by x. Look here, 3x over x minus 2x squared over x, right? Because I have x here, I have x here, and I have x here. So I separated the denominator with the common denominator. So this way I will end up with negative 3 over 7, 3 minus 2x, right? 3 minus 2x. So now if I take derivative, y prime, it's going to be equal negative 3 over 7, it's a constant, will come out. And in parentheses, what we will have left? We will have left, the derivative of 3 will be 0, derivative of negative 2x, it's going to be negative 2, right? Negative 2, and that will be equal 6 over 7. And lastly, let me mark down as an A, B, C, and D. So y is equal 9 over 5 x to power 2. So I'm giving you case when you don't have x as a common denominator and have it separated and canceling. In that case, you can represent as a 9 over 5 x to power negative 2. See, avoiding quotient rule. I usually don't even use quotient rule. I represent as a turn into multiplication rule. And this is going to be equal 9 over 5, okay, y prime, let me write down, is equal 9 over 5 is a constant. Now negative 2 comes in front, x, and negative 2 minus 1 will be negative 3, right? And this will be equal negative 18 over 5, and negative x to negative 3 will come down, x cubed. Next, we are going to do derivatives of trig functions, trigonometric functions. So, d by dx of tangent x. We already know derivative for sine and cosine, right? Derivative of sine is cosine. Derivative of cosine is negative sine. How about derivative of tangent? It's going to be secant square x. Okay? Derivative of cotangent is going to be equal negative cosecant square x. Next, derivative of secant x is equal secant x tangent x, and derivative of cosecant x is equal negative cosecant x times cotangent x. Okay, so let's do basic examples for now. Y is equal, okay, example number 1. Y is equal x minus tangent x. So dy by dx, derivative, is equal, derivative of x is going to be 1. And derivative of tangent is going to be secant squared. So minus secant square x. Number 2, y is equal x times secant x. Now in this case, we have multiplication between them, right? Therefore, I'm going to apply rule of multiplication. So y prime here, it's going to be equal x times derivative of secant x plus secant x times derivative of x. So we are going to get x times derivative of secant. Where is it? Right here. It's going to be secant and tangent. Secant x, tangent x, plus secant x and derivative of x, it's going to be 1, right? So, okay, I can write down times 1, so you wouldn't wonder what happened. So, we have secant x as a common factor. We take out secant x and we will have x tangent x plus 1. Yes? Okay. Next example. So let's do y is equal 1 minus cosine x over sine x, and this is equal cosecant x minus cotangent x. So if the equations is equal, has equal sign, then derivatives also have to be equal. Let's show that. Let's show that. And I'm going to use different form of derivatives. Let's see. First, I'm taking care of 1 minus cosine x over sine x. Y is equal 1 minus cosine x. Let me rewrite nicely. That looks ugly. Cosine x over sine x. So y prime is equal. Quotient rule is equal. It tells us, so sine x times 1 minus cosine x, right? Minus 1 minus cosine x prime, which is derivative, and then minus 1 minus cosine x times prime of, prime I mean derivative, sine x, derivative of sine x, and divided by sine x, sine square x. Okay, just to remind you, the quotient rule, real quick, based on what I have used. If I have f of x divided by g of x, and I need to take prime, that is equal f prime of x times g of x minus g prime of x times f of x, and divided by g of x squared. Okay, that's a rule I just applied. So sine x times the cosine, 1 minus cosine x prime, and minus, so let's assume this is sine x is my g of x, yeah, and this is my f of x. No, it's not gonna work, f of x. Okay, so here we have g of x times f of x prime minus f of x times g of x prime. Okay, so let's solve it, see what we gonna get. At the y prime is equal sine x times derivative of 1. I am doing this one right now, prime of 1 minus cosine x. So derivative of 1 is 0. Derivative of cosine would be negative sine, right? But because we have here negative, then it's going to be, okay, I can write down, not a big deal. It's going to be times negative sine x. Yes? Because here we have minus, here it is, I am making it bold, minus. Okay? And derivative of cosine is negative sine. That's how we ended up with two negatives. Minus. How much is derivative of sine x? Is cosine x, right? So cosine x times 1 minus cosine x. And divided by sine square x. All right. So the result is going to be sine square x positive minus cosine x and plus cosine square x over sine square x. Now, look what I have here. Sine square x plus cosine square x. It's a famous formula that says cosine square x plus sine square x is equal 1. So from here, y prime is equal 1 minus cosine x over sine square x. Okay? So this is what we got from the derivatives of 1 minus cosine x over sine x. Now let's take derivative of cosecant x minus cotangent x. Cosecant x minus cotangent x prime. Okay? So y prime is equal cosecant x minus cotangent x. So what do we have? Derivative of cosecant x is going to be, if we open this formula here, here it is, negative cosecant times cotangent, right? So I'm going to write down right here, negative cosecant times cotangent x and plus cosecant x squared, because derivative of cotangent is negative cosecant square. Here we have, here, cosecant square x. Therefore, it's going to be equal plus cosecant square x. All right, so look what we got for 1 minus the cosine x over sine x. We got this as a derivative, and for the right side of the equation, which is cosecant minus cotangent, we got this as a derivative. Now let's see if they are equal to each other. So I'm taking 1 minus cosine x over sine square x. So separating common denominator, 1 over sine square x minus cosine over sine square x. Now what do we have? 1 over sine square x, right? We know that 1 over sine x is cosecant x. But 1 over sine square x will be cosecant square x, right? Okay, minus. Now let me do some drafting here over, let me move this down, drafting over cosine over sine squared. So I'm going to separate 1 over sine x and times cosine x over sine x. Why am I doing? Because we don't have formula where sine is used as a squared. Okay, so besides of sine square plus besides of this formula, and this formula is not related anyhow. Therefore, obviously, logically, I'm trying to get rid of this square. That's how I'm doing. Since it's a multiplication here, I am breaking down 1 over sine squared times cosine over sine squared. And what does this give me? I am getting 1 over sine squared, 1 over sine x, it's going to be cosecant x, right? And cosine x over sine x, it's going to be cotangent x. Right? All right. So from here, what am I going to do? Cosecant square x minus cosecant x, cotangent x. If I compare to the derivative I got here, it is identical. Yes? So therefore, we can say that equation also valid. Okay. And lastly, let me bring several examples of higher order of derivatives. Higher order of derivatives. So, what can I do? I can take derivative several times up to nth derivative. Okay? If I am taking derivative first degree, I am marking down as f prime, either y prime or f prime of x, or dy by dx. Okay? And second derivative, I can put y double prime or f double prime. It's going to be second degree derivative. And here, since dy, it's a d is degree 1, now I have to put d degree 2, y over dx. Okay? Next, third derivative, 3 primes, f, third degree here. And here I will have, let me move this down so I will have space there. And that's going to be d third degree y over dx, and so on, which means it's going to be, if I have nth degree, it's going to be y to power well, nth degree, rather saying, put in parentheses, f of nth degree of x and d of nth degree of y over dx. Okay? So let's solve one problem, and that will be it. So we have f of x is equal 4x to 5 minus 2x cubed and plus 5x squared. We need to find f of degree, the derivative free. Okay? So, first I have to find first derivative, rather saying, second derivative, and then only then third derivative. So first derivative, f prime of x, it's going to be equal 4 times 5x to power 4 minus twice 3x to power 2 plus 5 times 2x. Okay? Let me simplify. This is equal 20x to 4, first derivative, minus 6x squared plus 10x. Okay, next, second derivative. So I'm taking from the first derivative. It's going to be 20 times 4x cubed minus 6 times 2x and plus 10. And the third derivative from here, it's going to be equal 20 times 4. I didn't multiply. It doesn't matter. I'll do now. Might as well write all together. 3x squared minus 6 times 2. And x is going to be gone because it's degree 1. So it's going to be simply 12, and plus it's going to be degree of 10, derivative of 10 is going to be 0 because we have constant. And result is 80 times 3, 240 x squared minus 12. This will be third derivative. Okie dokie. Hopefully it was helpful, and please put like so I will know if you like it, you are interested. And I'm going to post assignment with similar problems I covered, so you can practice and make sure you understood it. Okay? Okie dokie. See you in next video. Bye for now.